Hello students, welcome back to Akshar IIT Foundation classes, and I am your chemistry faculty S. Mohan. Students, in the 9th class, we are dealing with the chemical kinetics, and in the previous classes, we covered the first and second part of the chemical kinetics, and today I am going to discuss about the third synopsis. So students, here in the chemical kinetics third topic, this is the third part, third synopsis, we are discussing about the factors on which rate of reaction depends. Rate of reaction already we discussed. So how much time? Okay, simply if you would like to say how fast the reaction takes place, or that's called rate of reaction. Okay, so in the previous classes we discussed about the three types of reaction, like fast reactions, slow reactions, moderate reactions, and we also discussed about the like Arrhenius theory and so on. Right, in this chapter, in this topic, we are going to discuss on what factors the rate of reaction, or simply you can say the speed of reaction, depends. Okay, so since there are so many factors out there on which rate of reaction depends. Okay, so in this some important factors: nature of reactants and products. Nature of the reactants. So what is the nature of the reactants? Means are they ionic compounds? Are they covalent compounds? So what is the nature of the reactants and what type of products are forming? And nature of the reactants, again we see that, like are they solids or liquids and gases? So this comes under the nature of the reactants. Next, concentration of the reactants. Concentration, you know that, okay, how much? Okay, so concentration is there. Third one, temperature of the system. This plays very important role. And fourth one is catalyst. Did you learn about the catalyst in your classes up to 9th class? Catalyst means what? Which promotes the rate of reaction. Which promotes the rate of reaction without involving in the chemical reaction is called a catalyst. And of course, in the catalyst, again, two types of the positive catalyst and the negative catalyst. Okay, that we'll discuss. And then come to the surface area. Okay, and pH of the medium, electric and magnetic field, exposure of radiation, so many are there. But students, here in our class, we are going to discuss about first 5 factors only, right? So one is nature of reactants and product, concentration of the reactions, temperature, and catalyst, surface area. Okay, now let us see first one, nature of reactants. The nature of reactants, it depends on the physical state of the reactants. Physical state means what? They are solids, liquids, or gases. Okay, so generally the rate of reaction is more or higher in the gases when you compare to the liquids, when you compare to the solids. So physical state of the reactants and products is generally the rate of reaction for solids, liquids, and gases is following way. So gases is greater than liquids than the solids. So generally this is about the physical state. Okay, physical state of the reactants. During the physical state, what happens? The rate of reaction in the gases is greater than the liquids than the solids. Now what about the chemical? When you come to the chemical nature, generally the molecules which are more stable, if they participate in the chemical reaction, then the rate of reaction will be less. Why? Because here the molecules are already stable. Okay, so now we need to break the bond between them. Okay, in the previous class, the collision theory we have seen, for example, like two molecules are there. Okay, so this is A molecule and next one is a B molecule. Okay, so these are the two molecules. If you want to make the reaction between these two, then what should happen? First, the bond should be broken between these two. Then the bond should be broken between these two. Then these individual molecules, the bond will form, and here it also the bond will form. Right? So here this process will be there. Right? So that's what here. If the molecules are stable, the rate of reaction is less. So the meaning is what? Rate of reaction is inversely proportional to the stability. And you know that stability also depends on the number of bonds, right? So, rate of reaction is inversely proportional to the number of bonds also. Is this clear, students? So, now here you can see, yeah, the rate of reaction is inversely proportional to, inversely, see 1 by, it is the denominator, okay? So, inversely proportional to the stability of reactants, okay? So, or we can also write rate of reaction is also inversely proportional to number of bonds to be broken, Clear? Now, generally the rate of reaction, okay. So here you can see generally ionic reactions are faster. Ionic reactions are faster comparatively covalent compounds. Okay, the reaction between the ionic compounds is faster comparatively, okay, covalent compounds. Clear? So that is depending on the nature of the reactants. Clear? Okay. Now, for example, if you want me to explain, for example, take the two ionic compounds. Okay, ionic compounds reactions will take instantaneously. Okay, for example, sodium sulfate Na2SO4, and there's a ionic compound. If it's reacting with the barium chloride, BaCl2, barium chloride, ionic compound, when they mix with each other, instantaneously the reaction takes place, and we can get the new products called barium sulfate and sodium chloride. So ionic reactions are very fast. Like, I'll write the reaction. For example, barium chloride and sodium sulfate. So sodium sulfate formula is Na2SO4. Okay, and barium chloride, for example, you take BaCl2. Now, when the reaction takes place, actually, for example, if you take the two test tubes here, these are the two test tubes, and in this test tube, first in the test tube you take sodium sulfate solution, aqueous, okay, and the second one you take the aqueous solution of barium chloride, okay, barium chloride. Now, when you mix with each other, immediately a white precipitate is formed of barium sulfate, BaSO4. Okay, so the reaction is taking instantaneously, immediately they're taking place. Okay, so therefore the reaction between the ionic compounds is faster comparatively covalent reactions. So ionic reactions are faster than the molecular or covalent reactions. Clear? So that is about the nature of reactants, right? Then come to the concentration of the reactants. This as the concentration increases, rate of reaction increases. So concentration of the reactants is directly proportional to the rate of reaction. Okay. So here the rate of reaction is directly proportional to the concentration of reactants. Means what? As the concentration increases, the rate of reaction also increases. This is very simple. Okay. And here some example is given. Okay. Then come to the effect of temperature on the rate reaction. Effect of temperature. So students, here as the temperature increases, rate of reaction also increases. Means what? The reaction takes faster. Okay. One simple example I'll give. This is not like okay, chemical reaction, but just to understand. Okay, I'll give one small example. So for example, you take the 2 cups of milk. Take the 2 cups of milk. Okay, in 1 cup you take the cold milk, right? In another cup you take the hot milk, right? So you're taking the 2 cups of milk. Just for example, I'm telling. Okay, this is 1 cup and this is another cup. In this you take the normal milk, this cold milk, and in this you take the hot milk, right? Now take some sugar, okay, 1 spoon of sugar, and drop here, okay, and you see in which cup the sugar dissolves faster. Yes, very good. So sugar dissolves faster in the hot milk, right? So in the hot milk, sugar dissolves faster, correct? So why? Because the temperature is more here. If the temperature is more, the kinetic energy of the molecules is more, right? So as the temperature increases, your dissolution is increasing. Similar way, as the temperature increases, the rate of reactions also increases. Generally, okay. So generally, most of the reactions, okay, the rate of reaction is directly proportional to the temperature, okay. And it was observed that almost for every 10 degrees rise of temperature, the reaction rate becomes double, means faster, right? For example, For example, one reaction is taking place at a 25 degrees Celsius. 25 means what? At a normal temperature. Okay, our room temperature generally we consider like 25 degrees Celsius, right? Now at this temperature, in this room temperature, I am doing one experiment, some experiment, right? So here the complete the reaction is taking certain time. We can take T. Okay. Now what I am doing, the same reaction I am doing with a 35 degrees Celsius. Means what here I am increasing the temperature. I am increasing the temperature from 25 to 35 degrees. Means temperature increased. Temperature means what? It's a heat. It's a form of heat. So it's a form of energy. Okay. So here what happens? Here the temperature increases. Then the reaction take faster. Okay. So the meaning is what? Temperature is directly proportional to the rate of reaction. Right, students? So see now, in general, an increase in temperature increase the rate of almost all chemical reactions. So for almost all the chemical reactions, as the temperature increases, rate of reaction also increases. Similarly, if the temperature decreases, the rate also decreases. So on the other hand, a decrease in temperature decreases the rate. Decrease in temperature, decrease the rate. So if the temperature is decreased, the reaction will get slower. Right? Okay. Now see in the most cases, rise of 10 degrees Celsius gradually doubles the specific rate of the reaction. See, very important point here. For every rise in the 10 degrees Celsius, that generally doubles the specific rate of reaction. Okay. So that is about the relation between the temperature and rate of reaction. So as the temperature increases, the rate of reaction increases, and for every 10 degrees Celsius almost here the rate of reaction will be double faster. Clear? So that is you have to remember. So this is normal. Then come to the effect of catalyst. This is very important, students. Catalyst. Do you know what is the catalyst? Catalyst means what? Which promotes the rate of reaction. Which promotes the rate of reaction. The meaning is what? For example, and without being consumed. Without being consumed means what? For example, there is one reaction like nitrogen and hydrogen. Nitrogen and hydrogen are reacting to form the ammonia. Okay. So this reaction, in this reaction, generally, when it takes place under industrial process, we add some catalyst. Okay, like finely divided iron acts as a catalyst, and of course in that molybdenum is also we add that acts as a promoter. Okay, so here hydrogen reacting with nitrogen form ammonia. Okay, ammonia is what? NH3. So here nitrogen, that is what? For example N2, nitrogen. Okay, and hydrogen. Okay, so it's forming the ammonia NH3. So to balance it, we write the 2 here, 3 here. Okay, so that's all. This is the nitrogen and hydrogen forming ammonia. That's all. Nitrogen and hydrogen are there. But when it is industrially manufactured, the ammonia, in this finely divided iron is used as a catalyst. This we discuss in the later classes. Okay, finely divided iron is used as a catalyst. Okay, so here iron we are adding in this one. Can you see the iron here in the reactants or products? No. This just we are adding to promote the rate of reaction, to speed up the rate of reaction. So such substances which speeds up the rate of reaction is called a catalyst. Okay, so catalysts are being added to the chemical reaction. They just promote the rate of reaction, but they do not involve in the reaction. They do not involve in the formation of the products, from reactants to products. Clear? So they are called as a catalyst. So here generally catalyst helps the rate of reaction. Catalyst helps in the promotes the rate of reaction, that helps to speed up the reaction. Okay. So here see a catalyst is a chemical substance which alters the rate of reaction without participating in the reaction. The meaning is what? They are just promoting, they are increasing the speed of reaction, but they are not involving or participating in the chemical reaction. Such substances are called catalyst. Right? So these catalysts are of two types are there here. Presence of positive catalyst is one, presence of negative catalyst are there. Okay. So positive and then negative catalyst. Positive means what? Which generally promotes, okay, increases the rate of reaction, and negative means what? Which decreases the rate of reaction. So here you can see here, thus the rate of reaction increases. That's also the function of the catalyst is to lower the activation energy. So the greater the decrease in the activation energy, higher will be the rate of reaction. So here function of the catalyst is what? It lowers the activation energy. Means what? At lower temperature only, it will okay, allow the molecules to react with each other. So therefore, what happens? Higher will be the rate of reaction. So the rate of reaction will be increases. So these are called positive catalyst. Okay. Now what are the negative catalyst? Negative catalyst is nothing but the negative catalyst increases the activation energy. Means what? It makes the molecules to react at a more energy. Okay. So yesterday in the last class we discussed activation energy, the difference between the threshold energy and the energy possessed by the molecule is called activation energy, right? So here it makes that the molecule to react, it requires a more amount of energy. So due to that, what happens? So the rate of reaction will be decreases. What happens? Rate of reaction will be decreases. So positive catalyst increases the rate of reaction. Negative catalyst decreases the rate of reaction. So there are two types of catalysts. Okay. So that is about the catalyst. Okay, the last and final one, that is surface area. So as the surface area increases, the rate of reaction also increases. Surface area increases, the rate of reaction also increases. Okay. So surface area is directly proportional to rate of reaction. Okay. So the larger the surface area of the reactants, the faster the reaction occurs. So as the area of the surface increases, the rate of reaction also increases. So students, these are the factors that affect the rate of reaction. Okay. So students, with this our volume 1, okay, is finished. We completed the volume 1. Okay. So you will have the test already as intimated, and we'll be sending the revision worksheets for you. So revise that. Okay, and we'll intimate the date of exam. After the day exam, then we'll start the volume 2. Okay, students. So with this, we stop and take care. Revise perfectly.